we're going to solve equations and inequalities with roots and radicals here. So first thing we want to do is we want to isolate the root. So we want to get this root by itself here. So we can do that by adding this x over. So we could have the square root of x minus 11 is equal to x plus 1. Okay. Next, we want to raise to a power to eliminate. So to get rid of a square root, I want to square both sides. Now on this side, when I square this, I get 11 minus x. And when I square this, that means I have to write it times multiply it by itself. You give me x squared plus x, which is plus 2x, and plus 1. Next, I want to solve it. Okay, solve this answer. So notice this is a quadratic. So I want to get it equal to 0 to solve. So if I add that x over, it would be 3x. And if I subtract that 11 over, that would be negative 10. Okay, and in solving this, you can use factoring or quadratic formula or completing the square, whatever you feel comfortable with. Factoring doesn't always work, but it does in this case. So x plus 5 and x minus 2 will work. So I get x is equal to negative 5 and positive 2. Okay, now I have to, with these, just like sort of the other ones we've done, we have to check to make sure these answers work. So if I take a negative 5, 11 minus negative 5 would be 16. Square root of 16 is 4. 4 minus a negative 5 would be 9. Sorry, 4 minus a negative 5, yep, is 9. And 9 does not equal negative 1. So negative 5 is actually an answer that doesn't work, even though we worked it out. If we put a 2 in there, 11 minus 2 is 9. Square root of 9 is 3. 3 minus 2 is equal to 1. So that answer works. Okay, so that's the basic idea of how we solve these. So same thing here, number 2. This is like the square root, same sort of idea. So we want to get this, isolate that by itself first. So I'm going to subtract that over. So I have 5 minus 5x to the 1/2 is equal to 1 minus x, or negative x plus 1. You could go either way with that. Okay, so now when to get rid of the 1/2 power, remember exponent to exponent you multiply. So if I multiply it to the reciprocal, half of 2 would just be 1, so it would cancel out. And if I take this and square it, it means I multiply it by itself. I'd have 1 minus x is minus 2x, and plus x squared. Okay, so now I'm ready to solve this. So I'm going to keep my x squared positive here. I'm going to add the 5 over, so it'd be plus 3x. I'm going to subtract this 5 over, be minus 4. And once again, I can factor or use whatever method you'd like. Be x plus 4 and x minus 1. So my answers are negative 4 and 1. Okay, check them to make sure they're right. So if I plug in, and let's plug in the 1 first, that'd be 5. 5 minus 5 is 0. 0 squared is 0 to 1/2 power squared. The hair is square root of 0 is 0. 0 plus 1 equals 1. So 1 works. Negative 4, that would make that 20 plus 5 by 25. The square root of 25 is 5. Does 5 plus negative 4 equal 1? Yep. Okay, so they both work in this case. Okay, next one here. We already have the radicals isolated, so what we can do is just raise them both to the 3rd power. So 3rd and 3rd root cancel out. I have x squared plus 3x, and those cancel out, so I get 5. Okay, so once again, I have a quadratic to solve. I can get this equal to 0. And this one will not factor, so I have to use quadratic formula completing the square. So negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Okay, and if I work this out here, this is negative 3 plus or minus the square root of 929. Okay. You should check them. I will tell you that they both work. Okay, so that's your answer right there. Okay, number 4. This is going to get a little bit more complicated. Okay. So once again, we want to get kind of get this isolated over here. So square root of 2x plus 3, and I'm going to add this over to the other side. So this would be 1 plus the square root of x plus 1. Okay. Now I'm going to square both sides. So squaring this side and squaring this side. This side's easy to square, it's just 2x plus 3. This side I have to multiply it by itself. Okay. So 1 times 1 is 1. 1 times this is square root of x plus 1. This times 1 is the square root of x plus 1. And this times this would be the same thing as the square root of x plus 1 squared, which is really just x plus 1. Okay, combining like terms together, this would be x plus 1 on this side, and then plus 2 of these, 2 of this. Okay, so now this is kind of interesting because we have another square root here we need to get rid of, don't we? So what we need to do is get rid of this other stuff to the other side. So I'm going to subtract the 1, subtract the x over, so I'd have x, subtract x over, I have plus 2. Okay. Made a slight little mistake there. 1 plus 1 here makes 2 here. And if I subtract that 2 over, I have 1 here. Okay. So now, let's get rid of the square root by squaring both sides. So this here, x plus 1 times x plus 1 is x squared plus 1x plus 1x is 2x plus 1. If I square this, this makes that a 4, 2 squared. And if I square this, that gets rid of the square root, so you just have x plus 1. Now we're on to something. Okay, so now I'm going to move it over here. We have x squared plus 2x plus 1 is equal to 4x plus 4, which would be x squared, subtract that over, minus 2x, subtract that over, minus 3. So this is one that you can factor, and you get x is equal to 3 and negative 1. Okay, and I will tell you that when you plug them both in, that both of them will work. Okay. Okay, next one. So this one here, once again, we have the square root by itself already, so we can just square both sides. So x plus 4 times x plus 4 gives you x squared plus 4 is 8x plus 16 is equal to x plus 6. Okay, if I get stuff equal to 0, quadratic, so I have x squared, subtract that is minus 7x, subtract that plus 10. And this one is nice that I can factor and set them equal to 0. Okay. Now, if I plug this in here, and so this would be a plus 7 because I'm adding that over, right? So it'd be a positive and a positive, which makes these both negatives, negative 5 and negative 2. Okay. Now plug them in. Negative 5 plus 6 is 1. Square root of 1 is 1. But let's see what happens on the other side. Negative 5 plus 4 is negative 1. Can I ever have a square root equal negative 1? Nope. So that one doesn't work. Okay, if I plug negative 2 in there, negative 2 plus 6 is 4. Square root of 4 is 2. And negative 2 plus 4 is 2. So that one does work. Okay, so we do have that answer there that works. Okay, the sixth problem here, we have negative exponents, but we know what to do with those. This is the same as 15 over x squared minus 19 over x plus 6. Okay, we did some of these the other day. So to get rid of these, we're going to actually multiply everything by x squared. So those cancel, so I just have 15. X cancels, so I have 19x and plus 6x squared. And that times 0 is 0. So a lot of times we see that switched around, so let's switch it around real quick. Okay, and then we should look to see if we can factor. And factoring, oh, I forgot the x there. 3x and 2x, and let's see, I need negative 19 and negative 15. Let's see, 3 minus 5 and minus 3 gives us 15, and negative 9 and negative 10 give me negative 19. Okay, good. So when I solve this, you get positive 5/3, and that was a minus there. Add the 3 and divide by 2, I get positive 3/2. The solutions do check, and those are both your answers. Okay. So now we'll move on to inequalities. So the textbook has you look at where they're equal to 0. So if you look at this problem right here, this is the same problem we did up here. Okay, so we have the two solutions here. And then they want you to look at the graph. Okay, so if you think about what the graph looks like, if you could put it on Desmos, it would look something like this. Okay, so we have these two solutions right here, which were this right here. And if we want to put those in decimal form to know what they are, negative 3 plus the square root of 29 divided by 2 gives you 1.19, and then negative 3 minus the square root of 27 and divide by 2 gives you negative 4.19. Okay, so we have these two answers, negative 4.19 and 1.19, and we want to know where is it less than or equal to. Okay, so less than or equal to would be this part down here. Okay, now to get this graph, what we have to do is get this equal to 0, or y equals. So what we'd want to do to graph it is to y equals on Desmos the cubed root of x squared plus 3x, and we want to subtract this over minus the cubed root of 5. Okay, so you want to get it equal to 0, and then that 0 is really your y equals when you graph it in Desmos. And so you'd get a graph that looks like this. We want to know where it is less than or equal to, basically less than or equal to 0, right? So if I take this over there, where is it less than or equal to 0? It's less than or equal to 0 between these two. So that, if you use decimal, you can use that, or if I use the square root that I had on the other, this one would be the minus 1, and this would be that number, and it's or equal to, so I'm going to use brackets there. I'd be fine too if you put the decimal answer. The decimal answer, rounding it would be fine as well. Okay, so try and get it equal to 0, and then use the graph to see where it's greater than versus less than. Okay, so number 8, once again you want to get this equal to 0, so you're going to take the square root of 2x plus 3 minus the square root of x plus 1 minus 1. Okay, so you take this equation here after you subtract that 1 over and graph this. Okay, y equals this. And we did actually already solve this one. So that was this problem right here. We would solve it through. We know that 3 and negative 1 are our answers there. Okay, and if you would look at the graph, it looks something like this. Okay, so 3 and negative 1. So we want to know where it is greater than, okay, and it's greater than 0. So it's greater than 0 right in this area. So from 3 to infinity, it's greater than 0. So they very much take a graphical approach for these inequalities. Set them equal to 0, okay, find where it's equal to 0, and then look for where it's greater than or less than. Okay. Okay, this next one, we haven't done a fourth, but it's the same sort of idea. We're going to raise it to the 4th power, okay, to solve, because we haven't, the other ones we solved already, we haven't solved this one. So when we raise that to the 4th power, those cancel out. I have x minus 15, okay, and I'm solving where it's equal, and 2 to the 4th power is 16, so I get x equals, add that over, I get 31. Okay, and then looking at the graph here, okay, so I want to subtract this over, so I'd have the fourth root of x minus 15, and then minus 2. Okay, and this is like my zero, like y equals idea. Okay, so when I graph that, the graph looks like this. Okay, so right here is an asymptote at 15, and it starts here at negative 2 because it's minus 2, right? So it went down 2. Okay, but it starts here at 15. So from 15 all the way through here till 31, right? We found 31 there. You can't see that graph, sorry. Okay, so it starts here at asymptote at 15, because below 15, right, I can't have any x's that are negative, right? Below 15 wouldn't work, can't take this fourth root of them. And then comes up and crosses through here at 31, which we found right here. So where is this going to be greater? So if I greater than 0, so it's greater than 0 from 31 on, right? So it's greater than 0 from 31 through infinity, not or equal to, so we just use parentheses. Okay, the last two problems have some fraction exponents. Okay, we're going to deal with those a little bit for solving. So once again, okay, so this gets a little bit tricky, but it's not too bad. So what we're going to do is we're going to kind of use a substitution idea. If we think about this one, this would be the same as 2x to the 1/3 squared. Okay, because exponent to an exponent gives you this, and this would be 5x to the 1/3 minus 3. Okay, so notice we kind of have this x to the 1/3 is kind of like our variable here, right? Kind of using a substitution idea. So I'm going to say this is, I'm going to substitute a u in for x to the 1/3. Okay, so wherever I see x to the 1/3, I just put a u in its place. So notice I now have a quadratic to solve. So if I solve this quadratic, okay, that'd be 6 and minus 1 gives you the 5. Okay, and so I get u is either 1/2 or u is equal to negative 3. Okay, now I know u is this number here, so I'm actually saying that x to the 1/3 is equal to 1/2, where x to the 1/3 equals negative 3. Sorry. Okay, so we take this x to the 1/3, make it a u, and solve it there. So I know what u is, but u is equal to x to the 1/3, right? So I can just replace it back in. Okay, and then to get rid of the 1/3 power, I raise it to the third. Okay, 1/3 times 3 is 1, so I have x is equal to the 1/8. And then same thing here, raise it to the third power, those cancel out. I have x is equal to negative 27. And you should check your answers, take them and plug them in. I'll tell you that they both work when you plug them back in. Okay, let's do another one. Okay, so this would be the same thing as x minus 3 to the 1/5 squared. And this is 4x to the 1/5. Okay, so actually that's not going to work because notice in this one I kind of had the same exponents, right, that I can substitute in. I don't have the same things here, do I? So I don't want to use that method. Let's just okay, so they're both the 5th power. Let's raise them all to the 5th, both sides to the 5th. So if I do that, 2/5 times 5 would be 2. So I have x minus 3 squared, and that would be 1, so I just have 4x. That looks like it could work, okay? So now if I square this, that's x minus 3 times x minus 3, which is x squared minus 6x plus 9. Quadratic to solve, so get it equal to 0. And factor x minus 9 and x minus 1, so I get x equals 9 and 1. Okay, so yeah, that's how you can solve that. Then you could also go from the graph if you want to know where it's less than and greater than, go to the graph and do it there too. All right, so come to class with any questions or email me.